Finally, example 7. Which of the following statements are true, and if they're not, explain why. If the first derivative is greater than 0 and the second derivative is less than 0, then f is increasing at a decreasing rate. So let's translate. If the first derivative is greater than 0, this means increasing. If the second derivative is less than 0, this means concave down. So if we are increasing but concave down, this does mean that we are increasing at a decreasing rate. So this is true. Second, if f prime is greater than 0, that means that we are increasing. And the second derivative is equal to 0, then f has a local maximum. I'm increasing. I'm not even at a critical value, so I'm not even at a candidate for extrema, so this needs to be false. Okay, I need to explain why. So it's false because since f prime of c is not equal to 0 or doesn't exist, x equals c is not a candidate for extrema. So it couldn't possibly be a maximum. It's not even a candidate for an extrema. Two functions that differ by a vertical shift both increase and decrease in the same intervals. So if they differ by a vertical shift, they're going to have the same shape. They're just going to be above or below each other. So this should be true. Another explanation for it would be that they increase or decrease by a vertical shift. So if one of your functions is f of x, the other function would be f of x plus c, some constant. And if I differentiate both of these and find their derivatives, the derivative would be f prime of x, and it would be f prime of x plus 0, because the derivative of c is 0, and so they have the same derivative. And since they have the same derivative, they have the same intervals of increase, decrease. Okay. If f and g increase at an interval, then the product of f and g must also as well. So if you have two increasing functions, will the product also increase? This one's going to be false, because if I take the derivative of the product of f of x times g of x, we know that the product rule would apply. This is going to be f's derivative times g plus f times g's derivative. Now, I know that f and g increase, so I know that f prime and g prime are increasing. But what I don't know is what happens to the regular y values. So I can't guarantee that this is positive, because if these y values are negative, or if at least one of them is negative and the larger one's negative, this could come out negative. Okay, so it might be negative or positive. I don't know if it's negative or positive. So I cannot guarantee that it must also increase as well. It might, and it might not. So it may increase or decrease, depending on size and sign of f and g. I'm talking about their y values. Okay. Last, there exists a function f continuous on negative infinity to infinity with exactly 3 critical points, all of which correspond to minima. So it's continuous, so no breaks. If there are 3 points, all of which correspond to minima, it doesn't say that they have to be sharp or smooth, but they all have to be minima. So we'll make some minima here. If they're all minima and it's continuous, it's going to have to connect back through. And so if it has to connect back through, you have another critical point because you have a place where you have the derivative equals 0. Okay? So I can't connect between those in any way. That's not going to give me a new critical point. So this one's going to be false. They cannot all be minima. False, we must connect I'm getting set on. Must connect through those points to the rest of the points, creating some maxima. Alright, we're done with this section. Oops, can't see. We must connect through the rest of the points, creating some maxima.